Now we're live. There we go. Okay, so what we want to do as a precursor is we're really trying to find out how two lines intersect. So we're really looking at a system of two lines. Okay, when I say system means how does it intersect, okay? How do they intersect, okay? How do they intersect? System of two lines or system of equations one way to do it is graphing. Graphing works fine. I'm going to try and use two different colors because it's just easier to see if I use different colors, okay? So if I do the first equation, I'll graph in blue, and I'll graph the second equation in, let's see what other color do I have in here. I got a green. There we go, there's my green. Alright, so if you're colorblind, I'm not really helping you a whole lot at all, am I? So y equals 5 minus 2x. I'm going to start at 5 on the y-axis, right? I'm going to go up to 5, 1, 2, 3, 4, 5. The slope is down 2 over 1, 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 right? So my first line looks like this. Let's see, where's my ruler? There it is. So here's my first line. Call line 1. My second line has a y-intercept at -1, has an invisible slope of 1 over 1. So I'll go up 1 over 1, up 1 over 1, up 1 over 1. That right there. So the solution is the point, not the graph. The solution is the point. I'm going to write that down. The solution is 2, 1. Okay. Hopefully you've done this before, right? Thumbs up, you've done this before? Okay, good. Now example 2. I put example 2 on here for a reason. It's tedious. It's tedious to do by graphing, and there's an easier way to do it. So if we do it by graphing, equation 1, equation 2, I'll do equation 1 is 2x minus 3y equals 3. And what I want to do is make it look like this, y equals, okay? Because I can graph it. These were easy to graph. I said y equals 5 minus 2x. It said y equals x. So I want to solve for y. If I solve for y, then I'd have a slope and a y-intercept. Okay, so to solve for y, I'll do that. I'll go minus 2x, right? I'm just going to solve for y. That's minus 2. That's bad looking 2. A negative 3y equals a 3 minus 2x. You cannot subtract those. You guys remember that. Don't subtract those. That's a 3 and that's a 2x. You cannot combine them. Divide by negative 3, everything. Hopefully this is a review. Hopefully this is stuff you guys know. So I'll get y equals -1 plus 2/3 x. Okay? I can graph that. I can graph that for sure. Start at -1 as a y-intercept. I'll go up 2 over 3 is my slope. Okay. My second line I'll do in a different color. X plus 2y equals 5. Same thing. I've got to solve for y, right? So that I can have a slope and a y-intercept. So I'm going to solve for y. Y's here. Need to get everything away from the y. minus x, minus x. My first step, because I'll get rid of the x. Bring it over. X is gone, so I'll have a 2y equals a 5 minus x. You can't subtract those. One's a whole number, the other's an x. So you keep them separated. Divide by 2, divide by 2, divide by 2. Y equals 5 divided by 2 is 2.5, or 2.5, minus, I put a 1 here, minus a 1/2 x, okay? Now again, I already told you this is kind of the tedious way to do it, and there's a faster, better way to do it, but this is the way we've been doing it before. So I'll start at 2.5, and then I'll go down 1 over 2, down 1 over 2, and it looks as if they intersect right about there. There's my solution. Graphing quite often is the longest way to get this answers. We've learned other techniques in the past. You just don't remember it because we've had a long COVID winter. Okay? Catch up, okay? Graphing is the tedious way to do it. There's a better way, but when you do the better way, remember, we're really doing lines. So when I flip the page, we do it the better way, we're still doing lines, but we won't graph. Does that make sense? All we care about is one thing, where they intersect, okay? Flip the page. Now, elimination. Elimination is faster. So what I noticed, and I made this problem on purpose, I made it easy on purpose. What I noticed, again, this is a super easy problem, is the y and the negative y, right? Remember doing this in algebra or in geometry? If I were to add the two equations, what gets eliminated? Right, so if the y is gone, we'll just have x's and we can find out the value of x, right? So if I were to add straight down, the y's will cancel. I'll have a 3x equals 6, right? Divide by 3, and x is equal to 2. Now that's only part of the answer because what we're looking for are points, right? We're looking for points. So I have 2 something, and I need to know the something. So to find the corresponding y value, let's plug x equals 2 into either equation. It does not matter. But I'm going to plug 2 in either into the first equation or the second equation. It does not matter. Just for convenience, I'm just going to take it and plug it into the first equation, okay? And then I can find out what y is. So instead of writing 2x plus y equals 5, I'm going to put 2 right there in for x. So I'll go 2, and instead of writing x, I'll write the value of x, which is 2, plus y equals 5, right? So I replaced the value of x, which is 2, put 2 in its place. So instead of 2x, it's 2 times 2, which is 4, plus y equals 5. And then minus 4, y equals 1. So what's convenient is that we never graphed it, did we? Well, we know it's 2 lines, and we know they intersect at 2, 1, okay? Slide it up. Now, the second one, if I want to do it by elimination, what I need to do is make either the y's the opposites or the x's the opposite. It doesn't matter. We either want to cancel out the x's, boom, or cancel the y's, boom, but they won't cancel yet. So this is also called the multiplication elimination method. Multiplication now. So if I multiply, for instance, watch. This for negative 2x. Everybody watching? Negative 2x. That was negative 2x. That'd be nice, huh? So we multiply this equation by negative 2, they eliminate, right? That's probably what I'm going to do. Or I I could multiply this one by 2 and this one by 3. This one by 2 gives me negative 6. This one by 3 gives me a 6. They eliminate also, right? But I want to take the easiest way. Both will work. Let's just do the easy one. Okay, so I'm going to multiply this equation by negative 2. Multiply by negative 2, the x's will be eliminated. Okay, does that make sense? You've done this before, haven't you? Right, Emily?
Yeah.
Good. Okay, so I'm going to go ahead, multiply this whole equation by negative 2, and I'll rewrite the equation. So my equation's 2x minus 3y equals 3. And now I have a negative 2x minus 4y equals negative 10. And if I were to add them now, the x's are eliminated, right? So adding straight down, I get a negative 7y equals negative 7, because the x's are gone. They're eliminated. And then finding the value of y is pretty simple, because I'll just divide by negative 7. Negative 7 divided by negative 7 is 1. Okay, now that's only part of the answer, because we know we're looking for a point. We know the y value. We don't know the x. So my answer is something 1. Something 1, right? Well, I need to substitute. So I can take my 1 and I can plug it in for y, either the first or second equation. Which one do you want, first or second equation? Maybe the second, because there's no negatives. You guys okay with that? I'm probably going to put it into right there. That way I don't have to deal with negatives, okay? So I'm going to rewrite this. X plus 2y equals 5. And I'll put my 1 right there. So I'll rewrite this as x plus 2 times the value of y, which is 1, equals 5. And I'll just solve for the value of x. 2 times 1 is 2. Minus 2 minus 2. There it is. Okay. Now, finally, back to Bill's barnyard. Okay. We know that we have a head equation and we have a tails equation, right? So we have one animal. We have one animal, so we have pigs plus ducks together have 33 heads. Pigs have one head, ducks have one head, correct? Pigs have 4 legs, ducks have 2 legs, but we have a total of 96 legs. Could we solve it from there? Sure. Okay, homework today. I'll let you just think about that. I don't want to do it for you. I want you to just, I'd rather have you think. Nope.